Hello, my name is Chris Sanders. I'm the Director of Customer Reliability Engineering at RepliCon, and I'm here to talk about resolving issues faster with support bundles. If you're a replicated customer, you might recognize the Customer Reliability Engineering team members from interactions on support requests. Today, I want to talk to you about the other part of this team's job, building tools to make solving issues faster and easier. The tools we're building and using ourselves today are open source projects, which you can use to help identify and remediate issues for your products as well. I'm going to focus on two open source projects today primarily. The Troubleshoot project provides support bundles as well as collectors and analyzers to automate collection and analysis of your product and its environment. And the SBCuddle tool provides an intuitive interface to interact with a support bundle using the kubectl command you're likely already familiar with. I'll show you how we're using these tools, but I'd also like to invite you to join the conversation with these projects. Help us understand what new features would help you manage your application. If you're interested in developing the tooling yourself, join us for community meetings and contribute to the project. Let's look at the benefits these tools can provide and how you can start using them. Here's an example of a support request. An initial request comes in, the user states that their pod is not starting, and they provide the kubectl get pods as evidence that the pod is not healthy. Well, the support engineer looking at this immediately has to ask for more information. They need to describe the pod to see what's going on. So they do so and get back the information, and then they notice that the volume isn't mounting. But now they need to check the provisioner, in this case rooksef, to see why that might be happening. Again, they have to ask for information, and if they find out the pods are all healthy, which is good for the most part, but it means we still have a problem to find. So they have to ask for a command to be run inside the ceph operator pod so that they can check and see what might be going on. Finally, they've located that it appears that they're out of storage. Now we can talk about actual remediation of the root cause of the problem. This example is about storage providers, but I'm sure most of you can draw a correlation to your application. From databases to queuing systems, there are components that you might need to investigate that isn't obvious when the initial request comes in. Taking time to gather that correct information can be a significant portion of many support requests. Users of your software will have different levels of experience with Kubernetes and these components that go into making your application work. The Troubleshoot project and support bundles allow us to remove that burden of understanding of all of these various components from the end user to significantly reduce the root causing process. Let's take a look at what happens with a support bundle. Same request, but this time a support bundle was attached as matter of practice. Well, the support engineer is able to look at and identify the problem without asking for additional questions. As you can see here, by gathering relevant information up front, we can explore complex interactions between components without the user having to understand everything that might be involved in a particular failure condition. In this example, no additional information needs to be requested from the user. The kubectl commands, which were originally being requested for the user to run, are available for the engineer to run themselves, reducing time to investigate the issue and also removing the expectation that your end user understands Kubernetes. If you've ever wanted to just have access to explore your application directly yourself, that's what support bundles are providing for you. If you've ever worked with a legacy SOS log gathering tool from other products, that's a good correlation to Troubleshoot. However, because the applications that we're talking about are running on Kubernetes and Troubleshoot uses that, we have a defined API to gather a lot more than just logs. Regardless of which Kubernetes environment your application is deployed in, the API server gives you a common way to evaluate everything that's included with your application. Additionally, all that information is available via a defined API and accessible with tools like kubectl that you likely already know and use today. No more grepping through log files or looking through folder paths that you don't understand. Just tools you already know. So let's talk about how you can get started using these tools as fast as possible. So to get started on your journey with automating and reducing time to resolve issues, start by telling your users how to generate the bundle and request it on all support requests. If you're a replicated customer, your bundled application already includes a spec, which the COTS service will make available via the API. You can also collect bundles from the default spec on cots.io. The replicated community site and troubleshoot documentation detail additional options for how you can go about collecting bundles. The key is to make sure you get it documented for your customers so that they understand how to collect it and they do it with every support request. If you have to request a bundle after the fact, you've already added one additional round-trip delay to solving the issue. Ideally, you'll never need to ask for logs outside of the support bundle. We'll talk about that more in a minute. Once users are providing support bundles, your team needs to get familiar with the information in the bundle and see if it already has the information you need. It will already contain information on the health of pods, in your application, deployment details, log files, and config maps. If there are multiple people involved in reviewing an issue, either because you're a replicated customer requesting our help, or simply because you have several engineers working on a specific issue, the support bundle also provides a common shared understanding of the environment. Reducing friction and confusion between multiple parties is a pretty big benefit in and of itself. Replicated customers can also utilize the vendor portal to host support bundles, either to share with us or just to provide a centralized repository for storing and reviewing bundles with your team. The alias shown above is an example of one we use that makes working with vendor portal particularly easy. This command is using the shell subcommand of spcuttle and the optional token parameter to download a support bundle and immediately make it available. You can use this or similar commands to immediately review a support bundle directly from the vendor portal URL. No need to manually download the file first yourself. You can go from URL to kubectl commands in just a matter of seconds. It's one of the easiest ways to easily keep a whole team in sync on a given issue. Just this first step provides a significant improvement to your support workflow, allowing you to diagnose issues without the back and forth of a standard support process. There are even more benefits when multiple team members are involved and everyone knows where and how to access all of the information in a common way. That's not really the vision of support tooling ends though. Let's look at how you can take this further and reduce time to resolve issues more. While support bundles have a lot of good information today, they can surely be improved. If you have a support request and need to ask for additional information that the support bundle doesn't have, you should consider how to fix that for future cases. You can see the list of collectors that you can configure on the troubleshoot documentation linked here. The collectors can be configured to collect a wide range of information, so you can customize the bundle to include what's important to your application. The example before included information from within a running container on the cluster. Don't think of collectors as just logging information. Collectors can do more than that. For example, there are collectors to execute HTTP requests, to check connectivity, or gather information from APIs. You can execute into a pod to run commands, as we showed before. Finally, there's even a collector to run a pod of your own, which allows you significant flexibility in how you gather information. Collectors are powerful, extendable tools that go far beyond just collecting logs. If you can't collect something, let us know. Let's talk about what it might take to solve that. An example that we've been recently working on here at Replicated for our engineering team are host collectors. If you are a Replicated customer, you might have noticed information like free disk space, mount points, file permissions can be a common request from our engineers. Host collectors are adding a way to gather this sort of information about the host machine itself, so we don't have to keep asking for the information after the fact. When your team is using support bundles and collecting logs, you can then take the next step and put your knowledge into code. Rather than relying on someone to notice a critical line in a log file, you can check for failures and bring it to their attention. Provide remediation steps or guidance for what to do in known failure modes. Analyzers help scale knowledge internally across your organization. Those who know your product best can provide guidance via analyzers for anyone else that's trying to support your product. Rather than writing knowledge-based articles, which a team member may not know applies to their current issue, you can provide targeted advice based on the current condition of a specific environment. So stop writing flowcharts or how-to articles on how to root cause various issues. Let analyzers check it for you. Put it in code. If you're using Replicated to deliver your application, the results of analyzers are also displayed for the end user. There are a number of issues that your end user might need to involve another team. Expanding storage, adjusting firewalls, or investigating failures in internal services to a company like DNS often require those other teams. Being able to start those activities based on the result of an analyzer significantly reduces the time to resolution. Helping an end user understand an issue so they can remediate immediately is the fastest possible path. Analyzers provide a tool for you to present issues and remediation recommendations directly to your users. which can prevent some support requests entirely. Thank you for your time today. I hope I've inspired you to join us putting operational knowledge in code. If you're watching this pre-recorded video, there should be replicated individuals around to help answer questions. I'd like to leave you with one bonus topic. Contrary to the name, support bundles aren't just for support. Consider using support bundles for other activities in your company. Internal training, for example, can use support bundles to capture a known failure condition. They can be used for practice or examples in those training exercises. You could also use them for things like hiring, where a support bundle can provide a ready-made exercise to review with a candidate. Having a snapshot of an environment can provide benefits across your organization. I'd love to hear what interesting ways you start finding to use these support bundles.